welcome to today's tutorial. So today we're looking at, we're still under functions, but we're going to discuss a bit of the domain, the range, domain and the range of the function, and then we'll also look at the types of relations. And I'm sure we're going to start with the types of relations. From there we'll look at the domain and the range. Then after that we'll look at the linear functions and the equation of a straight line. Okay, so let's begin. So types of relations, we have what is called a many-to-one. So a relation is simply just a mapping from one set to another. So you can see we have one set here which is just the set of the domain, and then we have set B there which is just the set of the range. So when you see here we have we have many elements in this domain being mapped onto one function. So this is a situation where you have a function f of x is equal to something, where you put in, if you try to put in 1 there in f of x, let's say if you have x plus something this side, maybe x squared plus plus 2 plus what, you have a function in short. Then when you replace 1 there, you find the answer is 4. And then after putting in 2, the answer is still giving you 4. After putting in 3, the answer still gives you 4. So that one is, that kind of a function is known as a many-to-one function. Then we have a one-to-many function. So one-to-many function is a function where you have the domain there and the range. Then when you plug in the domain that you have there, let's say you have 1, 2, 3. You plug in 1, you get 3. You plug in 1, you get, you plug in one number and then you get maybe 2 answers, 3 and maybe 4. Yeah, and then you have this one being mapped onto many. You have one being mapped onto many elements in the set of the range. Yeah, so that's what it means when you talk about a one-to-many relation, which is also a function. Alright, there's also what is called a one-to-one function. So one-to-one function, sometimes they don't write it as one-to-one, they write it as one-to-one function. So this kind of a function maps one element from the set of a domain onto another one element, exactly one element, not more than one element on the range. Yeah, so from the domain you plug in 1, you get the answer that you get another, you get one answer in short. That one is called a one-to-one relation. Alright, so let's quickly move on and check another type of relation. So we have what is called an into function. So an into function, this one occurs when, for instance, you have the range of f. If you have the function f, which is a mapping, which is helping us to map A onto B, if this function f, if you find the range of this function f of x, you discover that the range is just a subset of a certain set, which is set B. So that implies that the given function or the given relation is an into function, because the answers that you are going to get after putting in the domain that you have this side, the answers that you are getting this side are simply just a subset of a certain given set, which is set B. Yeah, so when you have such an expression there, your answer, it means that you are dealing with an into relation. Yeah, so we're going to look at some examples, you understand better. So we have also what is known as an onto function. Alright, so first on the into function, there's this example here where you have 1, 2 is being mapped onto 3, then you also have 3 being mapped onto 4. So you have set B. Set B is simply just equal to 3, 4, and 5. So these, let me just say, set A is being mapped onto set B, and we've seen that only 2 elements have been used in set B. We have 1 element there which is remaining, which implies that the answers or the range of this function is simply just a subset of set B. So this means that this is an into relation. Let's look at what is called an onto relation. So an onto relation occurs when the range of a given function or a given relation is exactly as the domain of the range of a given relation is exactly as the domain of the other relation. Or let me put it this way: the range of a given relation, let's say you have 1, 2, 3, is exactly equal to the set which is set B, where you get maybe the answers are 1, 2, and 3 as well. So such an expression is called an onto function. So the range of the function f of x is equal to B, or we say the domain of f of x is equal to A. Then we conclude that that is an onto function. All right, let's look at an example. So of this example, so the example is just asking us to find the range of the following relations, these relations that we have. So it's asking us to find the range of these relations. So the domain has been given there. So the domain is simply just x is such that x is a member of real numbers. So to find the range of this function, they're asking us to find the range. So to find the range of this function, remember what I said when finding the range of any function, you simply just have to find the inverse of this function. So to find the inverse of this function, we're going to make x the subject of the formula in this expression. So when you make x the subject, we're going to take this 5 to the other side to have y minus 5 is equal to 3x. So 3x is equal to y minus 5. So we divide by 3, divide by 3. The answer that we're going to get is simply just y minus 5 over 3. So this is the inverse of this function. So having gotten the inverse, we can now conclude that the range of this function is, okay, we know to say the range of any given function is equivalent to the domain of its inverse function. So if this inverse, if we find the domain of this inverse function, then we conclude to say that is the range of this main function. So let us find the domain of this. So when you look at this function here, there's no way we can use any number to make this undefined. We don't have any. It's a rational function, yes, but the denominator there does not have any x value or any y value. It doesn't have any variable there. So there's no probability of us making this undefined. Hence we say the domain of this function, which is the inverse, the domain is just equal to x, such that, rather, we are using y in this case. Okay, let me do this. Every time you find the inverse of the inverse function, you switch the letters, you say. So the function will now be equal to y. Okay, let me just use y. Let me just say the domain is just equal to all real numbers. So we can plug any real number there, the function will still be defined. Alright. So now, since we have found this as a domain, so now we have found the domain of this function, which is the inverse of this function here. So what this means is that the range of this function is equal to the domain of its inverse. So the range is simply just going to be equal to all real numbers as well. Alright, so we are done with the first part, which is part A. Let us also find the range of this function given the domain as that. So for this one, it is straightforward. The domain has been given to say these are numbers ranging from 15, these are numbers that are between 15 and 250. So what we are going to do is that we're going to find the minimum and the maximum value of the range. And how do we do that? We get the minimum value. We're looking at numbers between 15 and 250, and they've told us to say this is a set of integers. So the next number in the line of integers, in the set of integers after 15, is simply 16. So to find the minimum value, we're going to use 16, and then to find the maximum value, the next number, let me just say the number that is just right before 250 is 249. The integer that is just right before 250. So to find the minimum value, we use 16. To find the maximum, we use 249. So this one is now easy. So let us find the maximum or the minimum value first. So the minimum value The minimum value will therefore be equal to, we replace this 16 in this expression. So we have 4 times 16 there minus 15. So the answer will give us 4 times 16, that is, so 4 times 16 will give you 64. 64, when you subtract 15 from 64, you are getting 49. So you have 49 as your answer there. So we do the same. So this is the minimum value. So let us also find the maximum value. So the maximum value is found by replacing 249 while there is x there. So we say 4 times 249 there, and say minus 15. So 4 times 249, yeah, so 4 times 249, you discover that the answer that you get is 996, and then when you subtract 15 there, you are getting 981. So you're getting 981 as the maximum value. Hence, the range of this function will therefore be equal to, so say the range will therefore be equal to, the minimum is 49, so we say 49, or let me start with writing m. So when finding the range, we're finding m, or finding m, so we say m is such that, so this m, the one that represents the range, m is such that we have 49 less than m, which is less than 981. So this is the range. This is the range of this function. Let's quickly move on. Okay, so this is what I was just talking about. This is what I was talking about. This one here. So this is what I just found. So this is the inverse, meaning the range of the function is just all real numbers. So the same applies to this one. We get the minimum by replacing 16 there, you get 49. Then you get the maximum by replacing 249, you get 981 there. Yeah, so from this expression, the one that I wrote here as the range, I forgot something. So the range was supposed to be written as m such that 49 less than m less than 981 was supposed to include that we are dealing with we're dealing with integers. So we say m is a member of integers. So I forgot to add this part, which is the what is the solution set. All right, so let's look at this example. So for this example, this one is straightforward. They have given us the function, this one, and they're asking us to find the domain. So they are saying determine the domain. So finding the domain is straightforward. You just get the first values there, because what you can see here, these are mappings. One is being mapped onto 2. It's like this. You have 1, 2, 3. I mean, 1 is being mapped onto 3 then. So 1, 2, 3. Then you have 2 to 1, 2 to 1. Then you have 3 to 2, 3 to 2. So it's a mapping. So the domain is this one, the range is this one. So they're asking us to find the domain. So the domain will simply just be equal to 1, 2, 3. Then the range will simply just be equal to 3, 1, 2, which is just the same as 1, 2, 3. 1, 2, 3. The first question is f a one-to-one function? Yes, you can see that the domain there, each domain is being mapped onto one range there. So yes, it's a one-to-one function. And then determine whether f is an onto function. Is f an onto function? Yes. Why do I say so? Because all the domains here, all the members of the domain have been mapped to all the members of the range. So it's just the same as writing that expression which I had there, where I would say this is being mapped onto this. So all the members of the domain are being mapped onto all the members of the range. So it's an onto function. The other question is determine the inverse of this function. So the inverse is straightforward. Let us find the inverse. So finding the inverse is straightforward. We can write the domains there. The domains we have 1, 2, 3. Then the range we have also 1, 2, 3. But of course 1 is being mapped on 2, 3 according to this one. Then 2 mapped on 2, 1, 2 mapped on 2, 1, 3 mapped on 2, 2. So to find the inverse, so the inverse of this function, I'm going to write the inverse there. So I have 1, 2, 3. So the inverse of this function, we know that the inverse, the domain of the inverse is equal to the range. So we have this one as our domain, then this one is our range. So the domain of the inverse function is equal to the range of the main function. So what I mean is that we have these 3 will be mapped onto 1, then these 2 will be, this one will be mapped onto, this one is being mapped onto 2 there, so it will go to 2 again. Then these 2 will be mapped onto 3 like that. So this is how you find the inverse. This is the inverse. So now let us find f of f inverse. So f of f inverse is also straightforward. We can have, okay, let me just display what I've just solved here. Yeah, so this is the inverse. This is how you find the inverse. So let us now find f of f inverse. So f of f inverse, f of x, this one can be written as f of, while there is x there, we put f inverse of x. So what we have here, the domain that we have is 1, 2, 3. So I'll start with 1. So I'm going to put 1 there. So I'll say f of f inverse of 1. So this is what I have. So f inverse of 1 will give me f inverse of 1, where is 1? Well, f inverse of 1 will give me 2. So this is just the same as, where there's f inverse of 1, I'll put 2. So f of 2 will simply just give me 1. F of 2 will give me 1. So to find the other one, we say f of f inverse of 2. We put the domain there, which is 2. So f inverse of 2, f inverse of 2 will give me 3. Wait, f inverse of 2, yes, it will give me 3. So I'll put 3 there. Then f of 3 will give me 2. So same applies to the last part there. We put 3 there. So f inverse of 3. So we have f of we have 2, f of 1. F of 1 will give me f of 3 will give me 1. F inverse of 3 will give me 1 there if you check. And then if we find f of 1, the answer is 3. So this is the f inverse of, so you can write that f of f inverse of 1, simply just 1, 2, 3. Yeah, so these are the answers there that you are supposed to find. Alright, so let's quickly move on to the next question. Alright, so let's move on. Okay, so this is what I was just doing. Okay, so we have another question there, which is an example, which says, let f of x be equal to x squared where 0 less x less 2. Yeah, so the first one is asking us to find the range. So the range of that function is also straightforward. What you just need to do is is also straightforward. So to find the range of this function, just replace you replace 0 there to find the minimum. You also replace 2 to find the maximum. So we're going to put 0 there. So find f of 0 rather is equal to 0 squared, which is just equal to 0. So this is the minimum. Then to find the maximum, so I'm getting the actual numbers. In the previous question, I got numbers between. So we had, in the previous question, we had That was 15 to 250. So I got 16 to 249 because the symbols that were used in the previous question were these. But in this case, you can see we have less or equal to, less or equal to, which implies that we should start from 0 and 2. So meaning 0 and 2 are part of the solution set. So we are supposed to get 0 and 2. But in the previous question, this one, which one? This one. When you look at this solution set that was given, this one implies that 15 is not part of the set, even 250 is not part of the set. We're just talking about integers between 15 and 250. That's why we got 49 and 249. Okay. So here we replace 0. We find f of 0. We get 0 squared, then which gives us 0. Then we also find f of 2. F of 2 will give us 2 squared, which will give us 4. So this is what we have. Okay, so the range will therefore be equal to. So this one, we've not been given the set of numbers that we're dealing with. Now, since we're dealing with inequalities and the set of numbers is not given, we assume that we're dealing with real numbers. Hence, we're going to say the range is going to be equal to from, so say this will just be, let me say open brackets, we say x. Okay, x is such that, not really x, but f of x. Okay, let me just write it this way. So we know that the minimum we found was 0, then the maximum was 4. So the range is simply just from 0 less or equal to f of x less or equal to 4. So the range, it ranges from 0 to 4. So f of x ranges from 0 to 4. So this is the range. Alright, so the other way you can write the range, you can just say r is equal to, or r implies that f of x is equal to, r implies that f of x is equal to, you just say, you write this in interval notation, meaning we are saying we're closing at 0, comma, we close at 4. It's also correct. And then the other question is asking us to prove whether f is a one-to-one function. So proving this, we have to make sure that f of x1 is equal to f of x2. Or the other thing that we can do is we can, instead of using x1 and x2, we can say f of a should be equal to f of b. So after finding this solution for this one, the answer for this expression to qualify to be a one-to-one function, the answer should be x1 is equal to x2. For this one, if you are using a and b, the answer should be a is equal to b. So when you find this, it means that the function is a one-to-one function. Or if you find this, if you are using x1 and x2, it means that the function is a one-to-one function. So let us try to do that. So I said we're going to use x1 and x2. Or let me use a and b for the sake of understanding. So we say f of a is equal to f of b. So we replace where there is x there, we put a, and then this side where there is x, we put b. So we're going to say a to the power 2 is equal to b to the power 2. We've replaced where there is x with a and b. So we have a squared is equal to b squared. So we'll take this b to the other side of the equal sign. We'll have a squared minus b squared, which is just equal to 0. So from there, you can now say this one is the difference of two squares, meaning you can write it as a plus b and then a minus b. So this one is equal to 0. So when you equate a plus b to 0, we're going to get that. Then when you equate a minus b to 0, we'll also get that. So a plus b will take b to the other side of the equal sign. This will be a is equal to negative b. And then this one will be a is equal to positive b. So you can see that these two are two different expressions. This one has a negative on b, this one has a positive on b, meaning they are not the same. So if we had found both to be a is equal to b, the answer would have been this one is a one-to-one function. So since these two are different, we conclude that this one is not a one-to-one function. Okay, let's quickly move on to determining whether this has an inverse or not. So to determine whether it has an inverse or not, we simply just have to find the inverse of this function. So to find the inverse of that, we're going to say let y be equal to x squared. So we make x the subject, so we're going to say x squared is equal to 1, and then we say x is equal to 1, so we have squared there, so we say square root, we have plus or minus, so this square and that will cancel, so we're going to have x is equal to plus or minus the square root of y. So this is the inverse of this function. So this implies that it has an inverse. Okay, so to write the inverse, you can just say f inverse of y, because this is now a function of y, is equal to plus or minus the root of 1. Okay, so that is how you can write it. Okay, so let's quickly move on. I think this was the last question. Then we are supposed to start linear functions, yeah, but we will not start. We're going to start in the next lesson, so that I give you time to first go through the relations and how to find the range, and how to determine whether a function is a one-to-one or it's an onto function or an into function. Alright, so thank you very much for watching today's lecture. Let's meet in the next lecture that we are going to have. My name is Harmtedy. Shalom, shalom.